A very difficult puzzle, and it is very peculiar, I will say. We have 4 given examples, and the grids in all the inputs are 30 by 30, okay? The outputs have different sizes, okay? So the first thing we gotta do usually is to figure out the correct size of the output, okay? And in this case, what we notice by looking at all the 4 examples is that there are some shapes that are colored light blue, and these shapes that are colored light blue appear to be in exactly the same dimension of the output. And most importantly, this light blue color is not present in the rest of this messy image, okay? This messy input. So we see the light blue here, and we don't see any light blue over here. So this is 5 by 4, so the output is going to be 5 by 4. And same thing here, we have this rectangle here, 4 by 9, and so the output is 4 by 9. And the fourth one, we have 7 by 3, and so this is 7 by 3. So first thing, we figure out the size of the output grid, okay? It's gonna be clearly 3 by 9, okay? It's gonna be 3 by 9. So this is the size of the output grid. Now, the next thing we gotta notice is that there are clearly some symmetries. We notice by looking at the center of this first input, we see this shape formed by the pink color, okay? And it's repeated over here, so we assume there's a symmetry that goes like this. And there's also a symmetry that goes the other way, okay? So we see this red shape and it repeats here, okay? So this shape has several symmetries, okay? This is what we gotta understand. So clearly, since all of this right part is symmetric with this left part, the way this light blue square must be filled is with the colors that correspond to the other side, okay? So this is like we cropped a part of this image and we gotta figure out what was here, okay? And we figure it out by looking at what happens in the symmetric part, okay? This is basically what we are doing, okay? However, we'll see that this is not quite enough. Let's start by doing this process on this output grid, okay? So if we notice over here, we have blue, green, red, okay? And we have the same blue, green, red over here. So we start by placing this color, the 9th color, here, okay? Sorry, edit, like this, okay? Because this is what the next color would be in this color, in this corner over here, okay? So we continue and we go down, okay? We go down following this column over here, okay? So there are 4 like this, orange, then we have blue, pink, blue, okay? Blue, pink, blue, like so. And the question is now, how do we figure out these ones? And this is the most difficult part of the puzzle, okay? But first of all, there's something else we can figure out because there's the other symmetry, okay? We notice that this is orange, orange, red, 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 pink, pink, and so on. So there's a line of symmetry over here, and if we move the mouse, we see that this line of symmetry is in fact over here, okay? So basically, let me fill all of this with light blue. We know that there is going to be a line of symmetry over here, okay? So for example, if we figure out that this one is, for example, pink, sorry, not the whole thing. If we figure out that this square over here is pink, then we know that this is pink. If we figure out that this square over here is pink, then this is pink, and so on. Okay, so this is what we figured out. Okay. However, we don't know quite yet these colors over here. We only know that these 4 squares are symmetric with these 4 squares. As for these other ones, this is supposed to be pink. Okay. As for these 5 other ones, well, 10 other ones, these ones are going to be symmetric with whatever happens over here. So we have 4 yellow, so this is a yellow square. Then we have 4 pink, okay, and then we have a blue on the edge and a pink over here. Okay, so we are only in fact missing these 8, and this is the part that truthfully took me quite a bit of time to figure out. Okay, and I'm gonna explain, of course, how to solve this. So if we look at diagonals now, okay, so clearly we notice that there's a symmetry on, the horizontal axis and the asymmetry on the vertical axis. We haven't looked at diagonals yet. Okay, so if we think maybe there's some pattern that starts with a diagonal over here, okay, and goes like this, okay, and in fact if we start a diagonal from this square over here, we see we don't know this color, but then we have orange, 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 and so on. Okay, so I mean, it wouldn't make sense if these 2 squares were in any other color that was orange. Okay, then again, we know these 4 squares are symmetric, so we know this is orange and this is orange. Okay, we are missing 4 more squares. So we look at this diagonal now, and we see we don't know this color. Then we have yellow, orange, pink. Then we have orange, yellow, orange, yellow, orange, yellow, orange. We have a pink, and then we have orange, yellow, orange. Okay, so there are only 3 different colors on this diagonal: orange, yellow, and pink. Let's try to figure out if there's some pattern. Okay, so we see this pink appears to happen only when there's a diagonal. Okay, we see there's a diagonal of pink, and then the 9th color. There's a diagonal pink over here, and then this 9th color. Okay, and these are the only cases in which the pink appears. Okay, if we see the case over here, we will have to assume that there's a diagonal that continues here, but as you can see, there's no such diagonal. Okay, so we can probably assume that the color over here is gonna be either yellow or orange. Okay, and what's the most likely? We see if we see this diagonal again, we see yellow, orange, pink, orange, yellow, orange, yellow, orange. It seems that it doesn't ever repeat the same color twice. Okay, so the color that likely makes the most sense over here is in fact orange, because if we put yellow, then it's the only time in this whole diagonal that it repeats the same color twice. Okay, so this is orange, and for symmetry this is going to be orange as well. Okay, then we see for the last one, we see this diagonal over here, and we have orange that we know, color that we must figure out, 9th color. Okay, then we have red, 9th color, red, 9th color, red, orange, red, 9th color, red, 9th color, red, 9th color, and so on. Okay, so it seems there's a very similar situation in which the same color does not repeat ever. Okay, And the only exception is where there's an orange color, but the orange color only appears like before if we are on a diagonal, okay? So there's clearly this diagonal of all yellow colors, then orange colors, and then yellow colors, okay? So there's clearly a pattern that alternates the red with the ninth color, okay? So the color that makes sense is red, because we don't want to repeat the same color on this diagonal, okay? And for symmetry, this is going to be red. So there are no color left to figure out, and so this is the solution, and it's correct.